dilations. A dilation changes the size of a figure, but not its shape. After a dilation, the angles of the image are congruent to the angles of the pre-image, but the side lengths will either be longer or shorter. The special name for figures whose angles are congruent but whose sides are not would be what? What do we call those two figures if they have the same shape but not the same size? Similar. All right, so dilations in the coordinate plane. For dilations centered at the origin, your xy rule turns into k, times x and k times y, where k is the scale factor. The center of dilation is a fixed point from which all points of the pre-image are either enlarged or reduced. So whenever you look at like the picture below, if you have C as your center of dilation and then you have this segment PQ and you dilate it, you enlarge it to P prime, Q prime, you should always be able to draw an auxiliary line from the center of dilation through P and its prime. Okay, so you should be able to draw a straight line that connects all three of those. If you cannot draw that straight line in the dilation, you have done the dilation wrong. Okay? All right, the scale factor describes how much the figure is enlarged or reduced. So if your k is greater than 1, you have an enlargement. If your k is between 0 and 1, you have a reduction. All right. So for each scale factor below, state whether it produces an enlargement or a reduction. So if your k equals 4, which one is it? Enlargement. .6. Reduction. 1/3. And 5/3. 5/6. What if we had, let's say, 7/5? What would that be? Enlargement. Good. Just want to make sure you understand that all fractions are not reductions. Okay? All right. Example 2. We have the dilation of 2/3 x and 2/3 y with center of dilation at 0, 0. Apply that to the polygon ABCD, where the coordinates what are the coordinates of the image? So what we are doing is we are taking -9, we're multiplying it by 2/3. And then we're taking 0 and we're multiplying it by 2/3. Okay, so A prime -9, remember if we do a whole number times a fraction, we do -9 times the numerator, so that gives us -18 divided by 3, which would give us -6. So A prime would be at -6, and then 0 times anything is 0. Any questions there? Alright, so B prime, we're taking 3 times 2/3, and we're taking 9 times 2/3. So where would B prime be? What would 3 times 2/3 be? 2. And what's 9 times 2/3? 6. Any questions there? Okay, C prime. You don't need the work, you can just do it in your head. What's 9 times 2/3? We've already done it. 6. And then what's 0 times 2/3? 0. And then D prime, -3 times 2/3? -2. And -9 times 2/3? -6. Any questions there? All right. Number 3, find the center of dilation and scale factor for the dilation that maps the solid line figure to the dashed line figure. So first off, if we're going solid to dotted, did we do an enlargement or a reduction? Reduction. Good. So we are going about the origin. So we can identify that first. I'm going to change colors. So center of dilation is the origin. Good luck tonight. Go get them. All right, so now, how do we figure out how much did we reduce from each point? So we look at the point. This is 0, 4, correct? And then what's its A prime here? 0, 2. So what do you think we've done there? Half. So let's double check the other points. So this point over here is -4, -4. And this point here is -2, -2. Did we take half of that point? Yeah. And then this point's 4, 4, 4, -4. And then this point is 2, -2. Did we take half of that point? Yes. So the question states that we did the center of dilation. Now what's the scale factor? So the scale factor is 1/2. And we did a reduction. Any questions there? All right. Okay, graph and label the image of triangle PIG. Just so you guys know, this is not supposed to be an R. It's supposed to be a G. Using the dilation centered at the origin with K equaling 3. So first thing we're going to do is write the coordinate rule. So x comma y transforms to, how would we write this if our K is 3? 3x and 3y. So there's our coordinate rule. And we're going to take each point and we're going to triple it. So if P starts at 3, 0, what's P prime going to be? 9, 0. I is at -1, 2. Multiply by 3, you get? Good. So I prime is at -3, 6. And then G is at 0, -2. So G prime will be at? Good. Now let's go graph it. So 9, 0. Get that straight edge out to make sure we have clean lines. And there's what your new triangle should look like. Any questions on that? Okay. Part B. Is this transformation an isometry? Why or why not? Right. No, because it's not a rigid transformation. It changed what? size. So no, not a rigid transformation. Dang it, I cannot spell today. There you go. All right. Next example, we've got this quadrilateral. Does anybody know what that quadrilateral is called? Trapezoid. Good job. All right, so we want to find, oh dang it, it's written in the instructions. I didn't realize that. Find the image of trapezoid PQRS using the dilation centered at the origin with a scale factor of 1/2. So let's write our coordinate rule first. So how would we write that? 1/2 x, comma 1/2 y. All right, so we're taking half of all these. So where's P prime going to end up? Q prime? R prime? Ah. -1, 0. And S prime. All right, let's graph them. It's a baby trapezoid. Is that what you guys got? Okay. Any questions there? Okie dokie. Next page. Bless you. All right, dilate circle C by a scale factor of 2 with a center of dilation at 5, -3. So this time we are not around the origin, we're going around a different point. So first off, circle C says its original center is at the origin. So here is C. And it says it has a radius of 2. So I go 2 away on each side, and I just stick a little dot there. And I do my absolute best to make a good circle. If you guys want, you can always use a compass if you'd like, okay? Not that serious. All right, my circles tend to look like rounded squares. Kind of like that, okay? Just an FYI. But if you're a perfectionist and you want to use a compass, you can use a compass. All right. Our center of dilation is not the origin. Our center is at 5, -3. So put a point there. I tend to call that point P, for which we're dilating about. Okay, so what we do whenever it's not at the origin is we work with slope. Okay, so you find the slope from point P to the center. Okay, so if we go up 1, 2, 3, we rise 3, and we run 1, 2, 3, 4, 5. And that's a -5 because we went to the left. Slope, remember, is rise over run, so make sure you go up or down first. So now you take that slope and you dilate it by a scale factor of 2. So that means I'm going to multiply this by 2. So instead of going up 3, I'm going to go up 6. And instead of going left 5, I'm going to go left 10. Any questions there? No? Okay, so we start at P. We're going to go up 6 and left 10. So there is C prime. Do you remember what we said about the dilation? We can always draw a straight line from the center of dilation through the point and its prime. Is there a straight line between those three? So did I do it correctly? Very good. So I've got my C prime. Where's it at? What's its ordered pair? Okay, so write that down. And then we need our radius. So if our radius started as 2, and our scale factor is 2, what's our new radius? 4. So our R prime is 4. So I'm going to go around C prime. I'm going to put little dots 4 away. And I'm going to make my rounded square. Very cool. Any questions there? Everybody good? Okay. All right, next, instead of a circle, we have a triangle. Our scale factor is how much? 1/2. So are we enlarging this guy or reducing him? Reducing him. So we want to reduce him towards the point -5, -8. So -5, -8. You need to put point P. So this triangle is going to get smaller towards point P. Okay? Now we're going to do the same exact thing that we did for the circle, but instead of doing slope for 1 point, we have to do slope for 3 points because it's a triangle. Does that make sense? So for F, we'll do, actually it starts with D prime. So let's do D first. So D's slope. Oh boy, count. How much do we go up? 16. And how much do we go to the right? 10. You guys know how to do that fast instead of counting each box? Okay, look at the numbers. P is at -8. D is at +8. So -8 to +8 is 16. P is at -5. D is at +5. So -5 to +5 is 10. Does that make sense? So you don't have to, I'm trying to help you not count each square, because that, you can get that wrong easily. All right, so what am I going to do with those numbers? Times by 1/2, which would be the same as doing what? Dividing it by 2. So we're going to divide this by 2, so that gives me a new slope of what? 8/5. So starting at point P, I'm going to go up 8 over right 5. So where do I end up? Origin. Very good. So that is D prime. If you take your protractor and you line up from point P through D prime and D, do you have a straight line? So did we do the point correct?
Yes.
Very good. All right, let's do, what's the next letter? Oh wait, we got to write down the origin for D prime. Okay, next letter is E. What's the slope to E? How much do we go up? 10. How much do we go to the right? 7. And what are we doing with that? Dividing by 2. Okay, so instead of going up 10, we're going to go up 5. Instead of going right 7, 7 cut in half is 3.5. That's perfectly fine to have a decimal. Right? So we're going to go up 5. We're going to go right 3.5. So just put it in the middle of the lines. So that is E prime. So then our ordered pair would be what? Where is E prime at? Good. Negative 1.5, negative 3. It's okay to have decimals. All right, now we got to do F. How much do we go up for F? 16. How much do we go to the right? 2. We're dividing by 2, so what are we going to have? 8 over 1. So we're going to go up 8, right 1. Where does F prime end up at? What's its ordered pair? Negative 4, 0. All right, get your protractor out. Draw a nice, pretty triangle, straight lines for D prime, E prime, F prime. Did we shrink towards point P? Very good. Do you have any questions? Okay. It says identify and describe the above transformations. So what did we do? What's it called whenever you shrink?
Reduction.
Reduction. So we write reduction by 1/2. So we reduced it by 1/2. Okay, now it says show algebraically that segment ED is parallel to segment E prime D prime. How have we learned to show two segments are parallel? Slope. And what do the slopes need to be? The same. So let's find their slopes. So ED. What's the slope from E to D? 6 over 3. Look at my staircase. What would that be? What's ED's slope?
2 over 1.
2 over 1. So we're going to write slope of ED is 2 over 1. Or you can just write 2. Okay, now we need to do slope of E prime D prime. Well, E prime kind of starts in the middle of a line, right? So I don't want to count that. I want to count just solid points. So I'm going to look right here to right here. What's that slope from a solid point to a solid point? 2. So slope of E prime D prime is 2 over 1 as well. So did we show the algebra for parallel? Yes, they have the same slope. All right, last one. We have to do a composition. So we've got to do 2 of them. Okay, so we're going to first dilate triangle JKL by a scale factor of 2 around negative 5, 2. And then we're going to reflect it over the x-axis. Okay? So let's draw the triangle first. Oh, whoops. Good job. Dang it. Means I gotta delete these segments. All right, now am I right? Good catch. Okay, what's my dilation rule up here? AX? What do we put in place of k? What are we doing? 2. 2x, 2y. Alright, so what's j prime going to be if we multiply by 2? Negative 6, 0. K prime? Negative 6, negative 4. And L prime? 2. Oh, wait a second. Are you guys going to tell me I'm wrong yet? What's wrong? Yeah, my center of rotation's not, or center of dilation isn't the origin, is it? No. So why y'all letting me write all this work? Where's my center of dilation? Negative 5, 2. Okay, let's try this again. We gotta count slope and then double it. So if j, we go down 2, right 2. So down 2, right 2, double it, what do we get? Negative 4 over 4, correct? Okay, so we're going to go down 4 from P and right 4 from P. So there is J prime. All right, K, we go down 4, right how many? 2. So times that by 2, what do we get? Down 8, right 4. So it goes down 8. That's all the way at the bottom. Right 4. So there is K prime. And then what about L? We go down 2 and right how many? 6? Is it? Up 1? 1, 2, 3, 4, 5, 6, 7, 8. You are correct. Okay, so here. Yeah, remember I said don't be afraid to tell me if my points are wrong. It gets a little with being this close. Alright, so times this one by 2, negative 4, 12. Is this one all the way on the side? Did I count that right? Yeah? Okay. Alright. There we go. So, J prime, its ordered pair, negative 1, negative 2. K prime, negative 1, how much is that? 2, 4, 6, negative 6. And then L prime, 2, 4, 6, 7. And down 2. Alright, we got all those points right? Okay. So we did the dilation, now we have to do the reflection. So what does the reflection say? X-axis? Who remembers our rule for reflection over the x-axis? Good. X opposite of y, correct? All right, well this one's easy. Remember x-axis, you can do it 2 ways. You can apply the rule or you can do equidistant. So I'm going to go ahead and just do equidistant real quick. J double prime, L double prime, and K double prime. So I'm going to do equidistant for my picture. I'm going to do both. So equidistance easier for my picture, and then for my points, I'm going to apply the rule to these points, because that'll make it easier as well. So negative 1, positive 2, negative 1, positive 6, and 7, positive 2. So I'm going to use both. Equidistant and the rule. All right, do we have any questions about dilations? No?